Hi everyone. In this video, we're going to talk about the store procedure and we're going to understand each and every concept and the syntax, like how we can build the store procedure from the scratch. I'm 100% sure you would have heard this word multiple times and you will be wondering whether it's really a complicated. Then in my opinion, no. If you know how to write a SQL query and if you know a little bit of syntax in any programming language, writing a store procedure is very easy. All it requires is to just understand the syntax, which I'm going to talk about, right? I'm going to use a PostgreSQL as a database where the stored procedures are known as functions as well. Whereas in other databases like Oracle, SQL Server, you will heard that, there is a minor difference between the function and the stored procedure. Like functions return some value, whereas the stored procedure is not. But here in PostgreSQL, since the stored procedure and the functions are being used interchangeably, it's the same concept in a PostgreSQL. So we can see the store procedure is going to be created with the help of this function keyword, which you can see on my screen, right? So let's get into the demo part and see how we can just understand and write our very first and simple hello world store procedure, right? As you can see on my screen, which I'm highlighting, this is the syntax. So let's dissect this syntax one by one. Create or replace means you wanted to create a new function on the store procedure, or replace means if that function is already there, then just override it, right? So it's just a defense mechanism in case you want to utilize, you can just leave that as. Then followed by the function keyword and then the function name. This function name can be anything, and then we have a parameter list where you have to pass the parameter, like how many parameter you want, but you have to align the parameter with the data type, right? Afterwards, you have this return and the return type. So what kind of return type, whether you want to return a text or a string or the table like structure like a record. Then this as and dollar, and in place of dollar you can sometimes see dollar body dollar as well. So this actually as double dollar symbol is just suggesting, okay, when you just run this code on a Postgres, it tells that now the actual function body is going to be started, where whatever the logic we have after this, you should execute that, right? So this is, and the very first thing which you have to write is begin. And then you have to have a very last line in the function, which is the actual execution code with and with, right? So this keyword begin and end has to be used. And then you have to have this semicolon at the end, and this double dollar symbols. Again, it's pretty much like, if you are coming from the Java world, we have a curly braces, right? So we opened with this double dollar symbol and then we are just closing it. And then we have to say the language PL, which is procedural language PostgreSQL, right? So this is the syntax which you will hear and you will see whenever you will get a hold on any store procedure in the Postgres side. So let's just build the very first a simple store procedure and try to execute, right? So I'm just copying this and I'm just going to paste it here in my Postgres. So I am already in a Postgres and you can see on my screen, same syntax, create or replace function, then the function name is say hello. And then we have a return that I mentioned and the return type is text, and as double dollar symbol, which says that now we are actually going to start our function body, and our function body will always start with the begin and it is going to end with end. Since we are returning it, so we have to use keyword return, and what we are returning hello world is. And then again, this is the pretty much fixed syntax that you have to close your double dollar. So you close that and then you have to use the language where you mention that PLPG is, right? Okay, so now your function is created. We can quickly check whether this is created or not. When you put a backslash df, which actually lists down all the functions which you have in a Postgres. So now we can see say how we can execute that. Very straight. Select, say hello, and then open and close parentheses. Okay, so it seems like there is a mistake I just made. I was having a spelling mistake. So let's say select. Now we can see the hello world is being written, right? So it's very straightforward. Now you understand whenever you see the store procedure, these lines which we have a start syntax and the end syntax, you should not be worried about returns and return, begin and end, right? All you need to care about is the logic which is actually written inside, right? The next thing is what we're gonna see how we can pass the parameter, right? So I'm just going to copy this part Here you can see we are passing earlier function. We don't have anything in our open and close parentheses, but now we have this username, and I mentioned that you have to use a data type. So we have a data type text, right? So we can just copy this function. We can just come here and you can just run. It seems like a problem here. Okay, so now we can see another function is created. We can just simply run the df function along, and now we can see we have a greet user function which we call, and we have to pass in the user. Again, what we're gonna do? Select greet user, and we can use whatever name we want. We can say Abhishek, right? And we can just run this again. Did I make a mistake somewhere? Okay. We cannot use a double quote here in a Postgres, so we have to just replace with a single quote. Let's run it. Now we can see, hello Abhishek, welcome to PostgreSQL. And because this is what we are returning here, if you just see the return of our store procedure or a function, right? The next one is, let's increase a little bit of, the complexity. Now we want to pass in, the radius. So we want to calculate the area of a circle. So we want to pass in the radius, and on a radius, which is a parameter, we want to apply some logic. So here, if you see, before returning, we are actually multiplying a radius with radius and the 3.14, which is the standard formula for calculating the area of a circle, right? So let's quickly copy this. It's very simple, straightforward. Now we have this. I just forgot to just mention, copy this last, which is really important, right? So let's quickly see whether this function is created or not. So it is actually giving a wrong. Now it's not created because the syntax was not completed, right? So what we can do, we can just copy this entire thing one more time. This point here, run this, and now we can again run the function df, and now we can see the calculate static area. So what we need to do, we can pass this 5 value, and we can quickly run this as select and see. Now we have the area. So now we know how to just create a store procedure or function where we can pass the parameters, right? Now just see the real-time example, because most of the time, not most of every time, whenever you are writing a store procedure or function, you are going to interact with the table, right? Because that is what we do in a database, right? So now let me create this table, which is an employee table, and it has 4 columns. ID, name, salary, and the department. And we can just insert some dummy record. We have 4 dummy records and just enter them. Now what we're going to do, we're going to create a function where we are going to get the employee count based on the department. Like in every department, how many employees we have, right? So let me just quickly copy this, create this here, and just see whether this is created or not. It's created. Let's quickly go through the syntax first, right? So this is the name which we have gave. Get employee count by the department, and we are accepting a department name as a text, right? Returns is integer because we have to return the count of the employee. So that's the reason we have taken an integer, because we are as double dollar. We know that this is declare. Now declare is actually a section we use. This is a new thing where we have to define the variable which we need for our function, just for to build our logic. So before begin, if you need any parameter where you want to save some change data which is having some kind of manipulation inside the function, then you have to define that parameter in the declare section, right? So now you have this amp count. So now what we are doing inside the begin, we have this select query. What this does, which is very straightforward, select count star. Now we have this syntax. Into is a very important keyword. Whatever the value you are getting from the select star, which is a single value going to be returned, you have to use into, and whatever the variable in which you want to store it, you can just give it a name. So whatever the result is going to be come out from this query, it is going to store in a amp count. And then from employees, we are department, and department is a department name which we are going to pass to the function when we are going to execute. Once we have this amp count populated with this query, we are returning that, and then and double dollar language and pgSQL, right? So let's quickly run this function by giving the IT as a department, and we know how many person we have with the IT. If you just see this, we have 2 employee with IT, right? If we just replace this with HR, then we should see 1. Now it's working. Right? So this is how the store procedure you can utilize. So what we are seeing so far is we can write a multiple queries. We can just have a variables inside it, and now we can include some if and else condition as well. So let's quickly get some conditional logic as well. Right. So what we are doing, we want to categorize the salary level. So how we can do this? This is the function which I have written, and we can quickly run this. Right. So let me just copy this. Okay. So let's quickly run this. Okay, so let's quickly see whether this is okay. So now we have this categorized salary. Now quickly understand that what this is doing. Again, we are seeing emp salary, which is numeric. What we want to categorize the salary. How we want to create it. So if the salary is less than 50,000, then we are saying it's slow. If it is greater than 50,000, but less than 65,000, we are saying medium. But if it's more than 65,000, then we are saying high. So now we can see this if else if else, right? So in if we are saying, okay, this emp salary, what we are getting in this parameter, we don't need to define or declare if we are using the same parameter, because by default this get as a variable for us, right? So we are checking whether it's less than 50,000. If yes, then return low. If it is in between the 50,000 and 65,000, this is the pretty much same syntax what we use in any programming language, right? And we are returning it. And then at the end, we are saying and if. So you have to just keep in mind, this is the syntax, because if else conditions is always different in every programming language with minor changes here and there. That's the reason you are seeing if else, and if, right? So this is the structure for if conditions, right? So how we can run this? Okay, let's quickly make some little bit of complexity over here. So if you just see what I'm doing, I'm trying to select a name and a salary, and I'm just calling this function by feeding a salary as a salary category from employee. So what is going to result? Let's see. We are getting a name and a salary from the employee team. But do we have this categorized salary? No, we don't have. So what we are doing on salary, we are applying this function. So basically, whatever the salary is being written for every record, that goes as a parameter to this categorized salary. And then we are analyzing this column with the salary category, and that is going to be written back. So now we are getting these three columns. Right? So this is a little bit complicated thing, how we can utilize the function to just add another column when we are going to run any select query, right? So now we have increased the complexity, and now we are going to just increase a little bit more complexity. Now what we're going to do is we are going to update the data, and now we are going to pass in the multiple parameter. As you can see on my screen, this is a give raise. Basically, we want to increase the raise for the employee based on the percentage. So we have to feed an employee ID as well as the raise percentage. Employee ID is integer and the raise percentage is numeric, right? So now let's quickly run this. Okay, let's quickly. Okay, so let's quickly run this. Cool. Okay, so let's quickly see whether the give raise is there or not. Okay, now we have a give raise and argument data types also. We can see here we have two parameters defined, emp ID and the raise percentage. How can we use that, right? So now if you just see the syntax of this, right, it's very straightforward. We have two fields which we are feeding, two parameters. Now we have a declare section with two variables, old salary, new salary in the emp name. Old salary, new salary is numeric and the emp name is text. We have a begin section. Now first what we are doing, we are extracting the salary and the name into the two variables, employee name and the old salary, because we have to change it. So that's the reason we are feeding the current salary to the old salary with the employee ID which we received here. Now what we're gonna see, we're gonna check whether the old salary is there or not. If it is there, if there is no old salary, it means that there is no employee exists with that employee ID. So we return that employee not found. That's good. Now we are saying if that's not the case, if we find the employee, what we need? We need to change, we need to just update the salary by just calculating the raise percentage. So how we can calculate this is a simple formula. Old salary multiplied by 1 plus the percentage divided by 100. And this is the syntax through which you can assign the value. So whatever the outcome of this expression, that is going to assign to new cell. And now if you want to update the data into the table, so we have to use the update statement. So that's the reason we are saying update. So in update, what we are doing, update employee set salary equals to new salary where ID equals to employee ID, which is a very simple SQL statement for update. Now in the return, what we are returning? We are returning a text because we said that we are returning a text. You can return anything, whatever you want. Here we are using a concatenated symbol, which is a 2-pipe. Then we can say emp name, salary updated, which is syntax with old salary to the new salary. So this is what we are returning, right? So let's quickly run this with employee ID 1. Let's see what happens. Okay, so now the John Doe salary is raised from 50,000 to 55,000 because what we have asked, we asked for the 10% raise. Let's see if I just feed in something which is not exist. One sec. See, we don't have ID. What we said? Oh, that's the reason we are going to do this. So we have to change the. We have to. Oh, one sec. So let's see. Employee not found, right? So we don't have that employee because we have only 4, right? Cool. I have to change that because I have to add the ID because, but anyways. Now, what happens if we want to, return a multiple rows? Again, this is a very realistic situation where we have to return a multiple rows, right? So here we have a little bit of new keyword which we need to keep in mind, right? So here, if you just see, we are returning a table. Table means you have a rows and a column which you want to return, right? And here you can say what column you want to return, right? So I want to return an employee name, employee salary, and employee department, and you have to define the type of that as well, so that when you are returning, it's actually a kind of a validation whether you are comply with this or not, right? So let's quickly create this. Okay. So let's quickly see. It's there. So we can see the return value as well with result set and what are the input. We have to just give a min salary, and what we are getting here, get higher earners. So what we are saying that we are passing a min salary. So based on the minimum salary, if you just see this query is very straightforward. Select name, salary, and a department from the employee where the salary is greater than the what salary you are feeding in. So whosoever is having a more salary than what value you are passing, it is going to result all those records and just return it back as a table. And for this, you have to use this query. So table is a new keyword to define the record you want to return. And when you want to return it, you have to use this query and then execute the query, right? So now if I run, so what we are saying, we just need those employees whose salary is more than 50,000, right? So let's see. Okay, so we have an error in line number 3. What this error says, structure of the query doesn't match the function result type. So basically it's saying that what result we are expecting, it's not matching it. So we have to understand how we have created our table. What is the structure of a table, right? So we can see quickly here. ID is serial, so name is varchar. But here what we are doing, we are returning text. So that's the reason. It's just wrong. So what we have to do, we have to just change the function definition. How we can do that? We try to change this function. Do that. We can quickly make this. And see if this works or not. If it is not, then what we're going to do, we are going to change in what used of function. Okay. So we can quickly drop function, which is get higher numbers, not an issue. Okay, and then we can just do this. Again, we can quickly verify it. Now we have a character varying, right? Let's quickly run the query again. Get high honors. See? Why? Oh, returning type character 50 doesn't match. Oh, why it is giving a 50? Is 50? Oh man. So let's alter the table. Table. So let's drop the table then. The table, what was the table? Employee. Okay, and let's quickly create the table again. I'm just changing that to text. Okay, there is that. Cool. So we can copy this. So there are many ways you can just fix this, but I really need to see why it was not doing that. So let's actually do text just to relay. Okay, but we can figure this out and I'll just let you know. Create this. Cool. Let's come here. Insert some records. Okay, that's also good. And then we can quickly just run this raise query so that we will be having that 1,000. Okay, so now we are good. So we can just quickly drop the function one more time. Function, and then we can just quickly run that function one more time. Now structure is matching with what we defined. So if we run this query now by applying that function from the table. Okay, so why it's saying that return type is carrying 50 doesn't match expected type. That's the problem 3. Why? We have this text now. One sec. We just not a function. Minus 2. Let me just figure this out. Okay, so the issue is now not only with the name, but with the department as well, right? Because in the department, what we are seeing, it's text, but if you just see the structure, where we are creating this, it's again varchar 50, right? So either we have to change this. Okay, so we already have that. So we can quickly fix this by just dropping the table one more time. Drop the table. Okay, and then we can just quickly create that table one more time. There is another way that we can change. Okay, like this text and we can just text here. Right, and we can cast that also if we want, but let's fix this because we have other things to cover. Okay, so this looks good. We can quickly run this. Okay, so now we have all the good information. Okay, so now we can get this get higher earner. So when we feed in 55,000, so the only one John Doe which we are not getting, right? So that's really awesome. Now, next to the little bit of more complexity here, what we're gonna do now? Conditional logic, we have just updated the data, we have just seen the multiple rows. Now we can just understand how we can handle the exception. We know that there can be a situation where we will get into some exceptions. Right? So it's pretty much same like what we have in a programming language. Here you can see, you can just verify. So we are safe divide. So basically what we are saying, numerator and the denominator. And we are seeing whether the denominator is a 0 or not. If it is 0, then we are raising an exception, and then we have this exception as well, right? So what it means, so there are some predefined exceptions. There are many more exceptions. If you will just look at the documentation, then you will find that there are many more exceptions which you can utilize. Others means this is just a kind of generic exception. If you just put others, and if due to any reason any of your logic is having any exception, it will always fall into this category. And then you can just handle that exception programmatically if you want, right? So let's quickly come here, run this, create the function. So you see, okay, we have this function as well. Safe divide. Sorry. Now what we can do, we can quickly run this worst case where we don't get anything and we just get the result. Okay, and then we can just run another one and then we can just divide with 0 and see the exception is being raised or not, right? So now we can see an error occurred, division by 0 is not allowed, right? It's good, right? So these are the scenarios which you can use. I hope I just cover all the basic thing. Now, depending upon what precisely you want, you can just write, the multiple SQL based code and the if and else condition, and the exception handling, and you can just make your SQL query pretty much same like how we write a logic, right? When do we need to do this, right? When do we need to use that, right? So here are some situation encapsulate complex business logic when you have a complex calculation of business rule that needs to be reused. What does that mean? Means that if you have a multiple applications, right, and you have to do the similar calculation again and again and the different logic by the different application, rather than doing it the application level, you should do that on a database level. So once you do it, it can be utilized by all uh, the applications, right? And you can just keep all those things in a reusable means like, I mean, if you have a same logic, which is different just because you have a different values at the different time, at that point of time also you can use this, right? And the other thing is like calculating complex report, processing a batch operations, implementing a business rules, data validation and transformation. Now we can understand all these things, right? The other thing is when you have a multiple SQL query which you are executing against the database, right? It's definitely reduce the network traffic because you are combining a multiple, the SQL queries into the stored procedures, right? Data integrity also you can, increase. The only disadvantages which you can see like database vendor lock-in, right? Because it's going to execute the code. If there is some code which is taking a little longer, then probably you will feel this lock-in situation. Debugging complexity is definitely, I can understand now it is having a new, syntax and keywords you need to keep in mind. Database code is really hard to just maintain the version control. We know that, but there are many, flywheel images through which flywheel versioning through which you can do that, right? So that's pretty much it from my side for this video. If you have any question or any suggestion, or if you want to just get into some more complicated scenario based thing, let me know. I will just try to help you because the store procedure is something which I'm really diving very deep into that because my current project is actually required me to understand the store procedure very thoroughly because we are going to migrate the store procedure to Microsoft Fabric. So I really need to understand what kind of logic we have in a complicated store procedure, and I have to convert that into the PySpark logic. Right. So that's pretty much it from my side. If you really like this video, give a thumbs up. And if you haven't subscribed for my channel, please subscribe for my channel as well. And please feel free to share this with your friends, colleagues, and groups if you feel like okay, this video can help them as well. And as always, thanks for watching this. Stay healthy and keep learning new things.